Hi, it's me again, Dr. Rahifa. In this video, you are going to learn how to find Fourier series of half-range function. At the end of this lesson, you should be able to solve the Fourier series of half-range function. Let's take a look at this example. The function given is ft equals t, where t from 0 to 2. We can see that it is a half-range function with L equals 2. The question is find the half-range Fourier series of the function using A, even function expansion, and the second question B, odd function expansion. To answer question A, first we need to plot the expansion into an even function in the interval t from -6 to 6, where L equals 2 and the period t is 4. When we do the plotting, first we need to sketch the half-range function ft equals to t from 0 to 2. When we do the plotting, first we need to sketch the half-range function ft equals t from 0 to 2. So this is the straight line of ft equals to t from 0 to 2. And to expand the function into an even function, we have to make sure that the expansion is symmetric about y-axis. The next step is to expand the plot between the interval t from -6 to 6. Since this is an even function, we're going to use Fourier cosine series formula to find the series, and this is the formula of Fourier cosine series. Using Fourier cosine series, we know that the Fourier coefficient Bn is 0. The next step is to find the Fourier coefficient A0, and this is the formula of A0. Substitute the L equals 2 and the function ft equals t into the formula and solve the integration. Integrate t is t squared on 2. Substituting the upper limit t equals to 2, subtract with the substitution of t equals 0 into the t squared on 2, we obtain the Fourier coefficient A0 is equal to. Next step is to find the Fourier coefficient An, and this is the formula of Fourier coefficient An. Substitute L equals to 2 and the function ft equals t into the formula. So we can see that the integration of t cos n pi t on 2 with respect to t requires a method of integration by parts or a tabular method to solve the integration. And here is the tabular method. In the differentiation column, we differentiate t 2 times until the differentiation becomes 0. In the integration column, we integrate cos n pi t on 2 twice. The first integration, we obtain 2 on n pi sin n pi t on 2, followed by the next integration, negative 4 over n pi squared cos n pi t on 2. We multiply the tabular method to obtain the solution of the integration equals 2t on n pi sin n pi t on 2 plus 4 over n pi squared cos n pi t on 2 with the limit from t equal to 0 to t equals 2. Substitute the upper limit to obtain these two terms minus the substitution of t equal to 0 into the resulting integration, we obtain this term. Note that the sin n pi equals 0, cos n pi equals negative 1 to the power of n. Therefore, the Fourier coefficient an equals 4 over n pi squared negative 1 to the power of n minus 1. The last step is to substitute the Fourier coefficients a0 and an into the Fourier series formula. Therefore, the Fourier series of the even function expansion is ft equals 1 plus the summation of the coefficient an times cos n pi t over 2, and the summation is from n equals to 1 to infinity. Let's move to the second question of the example. The question is, find the half-range Fourier series using the odd function expansion. First, we need to sketch the odd function expansion within the interval from t minus 6 to t equals 6, where the L is 2 and the period t equals 4. And this is the plot of the odd function expansion. Firstly, we need to sketch the half-range function t between 0 to 2 of the function ft equals t. The expansion of an odd function is symmetric about the origin. Therefore, this is how the expansion looks like. And then we just need to expand the function within the interval t from minus 6 to 6 by repeating the plot identically. Since it is an odd function, we're going to use Fourier sine series formula to find the series. And the formula is as shown here. We note that the Fourier coefficients a0 and an equal 0. The only coefficient that we need to find is Fourier coefficient bn, and the formula is 2 on L multiplied by the integration of ft sin n pi t on L with respect to t from 0 to L. We substitute the values of L equals 2 and the function ft equals t into the formula. So we can see that in order to solve the integration of t sine n pi t on 2 with respect to t, it requires an integration by parts method or tabular method. The table of tabular method is as shown here. In the differentiation column, the function t is differentiated until it becomes 0. And in the integration column, we integrate sine n pi t on 2 twice to obtain the first integration minus 2 on n pi cos n pi t on 2, and the second integration is minus 4 over n pi squared sine n pi t on 2. Cross multiplication of the tabular method, we obtain the solution of the integration is minus 2t on n pi cos n pi t on 2 plus 4 over n pi squared sine n pi t on 2, with the limit from t equals to 0 to t equals 2. Substitute the limit and we obtain this expression. Note that the cos n pi is minus 1 to the power of n, while the sin n pi equals 0. Therefore, the solution of the Fourier coefficient Bn equals 4 over n pi negative 1 to the power of n plus 1. Lastly, we just need to substitute the Fourier coefficients Bn into the formula of the Fourier series. The final answer is ft equals the summation of the coefficient Bn, 4 over n pi squared negative 1 to the power of n plus 1 sine n pi t on 2, and the summation is from n equals to 1 to infinity. In the next video, we are going to solve another example of half-range function. Thank you.